Hey, it's Zach, otherwise known as Grimpendango on the Discord. I'm here today to talk to you about Arcum Dagsson again with regards to cEDH, as always. Today, the topic is called What Are the Odds? Now, to better explain what I mean, I had this hand the other day, quite a while ago actually, but essentially, I drew this like a mulligan down low to 4, and this was my hand. It had an island, a mana vault, a damping sphere, and a metal worker. And basically, this hand presented me two choices. I could either, cast Metal Vault on turn 1 and then cast Metal Worker, and then hope to get a second artifact in order to cast Arcum on turn 2, or I could wait and cast Arcum on turn 2 and then hope to find a cheap artifact creature by turn 3 in order to activate Arcum. So this hand gave me two choices. And the way to decide on what to do here, it came down to some math. So this isn't you're not often going to be presented with that specific question, but when you're piloting this deck, you're going to sometimes need something that your hand doesn't have. And you're going to want to know what the probability of getting that certain thing is, and that can help inform gameplay decisions like mulliganing or what spell you're going to cast in a given turn. So some common questions you might want to know are: what are the chances of drawing an artifact creature, land, or mana source? A blue mana source specifically, perhaps even a blue pitch card or an artifact. And in case of Mox Diamond, it might even be what are the chances of drawing a real land. So, to help you understand this, the first thing I want to teach you is base odds. So base odds are if you're assuming that you have a full deck of cards, you have not drawn your opening 7 at all, and the deck is right next to you. If you look at the first card on top of your deck, what are the chances are that it is the card you are looking for? For example, if you're looking for a land and you've got 27 lands in your deck, what are the chances of that first card on the top of your deck being a land? That's what's called a base odd. That is where all your cards are in your deck, and what are the chances of you drawing a given card. And if you take away anything from this video today, it's to try and at least know what the base odds are, because they can help inform so many of your decisions. You may not be able to do hypergeometric math or anything like that, but just being able to know the base odds can really help you inform gameplay decisions and mulliganing decisions. So let's look at the base odds. I've already calculated them for you based on my deck, and my deck is based on the one Phyrexian's deck where he wrote one of the community primers, so I like to think it's fairly standard, although some might disagree. But in my deck, the base odds for getting an artifact creature are 26% roughly, and that includes 21 artifact creatures plus 5 man lands. 2 of those man lands are Urza Saga and Mirax. The base odds for getting a land or mana acceleration are 41%. That includes 27 lands, 8 mana rocks, of which the ones that are 4 CMC or lower, and 6 dorks. It's also worth noting that some of those are conditional. We've got Mox Diamond, Chrome Mox, and MGE, which are conditional mana rocks, and I'd also argue that dorks are conditional as well. So that's something to keep in mind as well. If you've got tapped mana sources, that's something to think about too. But generally speaking, it's 41% for mana sources in our deck. And then we've got blue mana sources, which is 26%, including 18 lands, 3 dorks, and 5 rocks. Again, Mox Diamond and Chrome Mox are conditional. And then the last two, which come up less frequently but are still relevant, are blue pitch cards, which is 32%, 5 enchantments, artifacts, 18 instances, 2 sorceries, and 4 creatures. Also worth noting that there's artifact versus non-artifact pitch cards, which is relevant for Chrome Mox. And the last one is, what are the chances of getting an artifact, which is relevant for the question we started with at the start of this video, and that's 51%, including 21 creatures, 30 artifacts, one of which is a land. So if you take nothing else away from this video, it's to know the base odds for your deck. And the base odds that matter most, I would say, are these ones, which is artifact creature, land or mana source, and blue mana source. Because blue mana source allows you to cast Arcum, lands allow you to ramp into Arcum, and artifact creatures allow you to activate Arcum. So you really should know these. But that being said, you might ask yourself, well, hey, if the chance of drawing an artifact creature is only 26%, how the heck are we able to draw so many artifact creatures? What the heck is going on here? The discrepancy you might think might be asking about there is that every time you draw a card from your deck, you're no longer relying on just the base probability anymore at deck construction time. There's one less card in your deck, so this 98 becomes 90, 99 becomes 98, but this 26 becomes potentially the same. So the probability of drawing an artifact creature goes up for every card you draw. And so just relying on base probability, which is total number of cards over the number of cards in your deck, that's not really a viable thing when you're trying to ask a question like, if I'm drawing, 7 cards or 9 cards by turn 2, what is the probability that I'm going to draw an artifact creature? If you're trying to ask a question like that, using just the base probabilities is insufficient. And there's this thing called hypergeometric probability, which allows you to take a base probability and convert that into a better probability, saying, if I'm drawing 9 cards for the first 3 turns, what are the chances that I draw an artifact creature? So there's a great tool you can use called the Aether Hub Hypergeometric. And if we look at that here, we've got, let's say we've got 92 cards. So we've drawn the opening 7, and we've got a great hand. And we go, okay, I've got a great hand. I can cast Arcum by turn 2, but I don't have an artifact creature. What are the chances of us drawing an artifact creature here? So the base probability, the number of successes is 26. Sample size is 3, which is the number of cards you're drawing. So for the first turn, you draw 1. Second turn, you draw 2. Third turn, you draw 3. So our sample size, the number of cards we're drawing is 3. And we want to go, and there are 26 successes, which is, artifact creatures in our deck. So if we run these numbers, it says, okay, we've kept a hand where we can cast Arcum very quickly. The chances of us getting an artifact creature by turn 3 is 63.6%. Not the best, but also not bad either. It's a lot better than 26%, which is what the base odds would tell us. So that's an example of using hypergeometric math to help you make a gameplay decision about whether you should mulligan or keep the hand. That being said, though, outside interference is still a real thing. You would not be able to pull out the hypergeometric math calculator in a tournament because it's considered outside assistance. So that's something to keep in mind as well. And we'll talk about some mental math options you can use instead as some shortcuts to get some quick hypergeometric math on your side when you need it. So, but before we get into that, let's just talk quickly about how you can use hypergeometric math. We've talked about what it is, which is, if you're, the chance of getting a specific outcome if you draw a bunch of cards, basically. So there are 2 different use cases really for hypergeometric. The first one is for deck construction. If you're building a deck, it can help you go, well, does my deck have enough of what it needs in order to function? For example, do I have enough mana acceleration to cast Arcum reliably by turn 3? That's a question you could ask yourself. Or do I have enough artifact creatures to be able to activate Arcum consistently within a game? Those are some things you can use with hypergeometric math. Now, it's worth noting with that, though, with mulligans, you're sort of resetting the game a little bit because you're drawing a lot more cards. So you can't just rely purely on hypergeometric math because every time you mulligan, you're replacing those cards back in your deck. So there's a little bit of, it's like you're drawing a lot of cards, but then you're replacing them. So the hypergeometric math doesn't work perfectly for that, but it can be useful, just in general. So that can help you answer questions like, do I have enough artifact creatures in my deck, or do I have enough blue sources in my deck to cast Arcum? So that's like the first use case for deck construction. But the one I want to focus on more today is around during a game. So you've during mulligans or during a game. So for example, let's say you can ask a question like, if I keep this hand, what are the chances of me drawing an artifact creature? And if the odds are low or high, then you might decide whether or not the acceleration in your hand is worth risking in order to, keep the hand and then hope that you draw the artifact creature you need. So that might be one example. So hypergeometric math can be really useful here because there you can actually, ask that real question that you need the answer to for that game or that hand that you're considering keeping or not. So looking back at it, again, hypergeometric math, we've got some things like population size, which is how many cards are left in your deck, sample size, which is the number of cards you're drawing, and success in population, which is the number of cards of a given type you're looking for. So here, for deck construction, usually population is 99, sample size is like 9 or 10, which is opening hand plus three cards. And then for deck mulligans, it's usually population is going to be 92 because you've already got 7 cards out of your deck. And sample size is usually going to be 2 or 3, which is, okay, drawing 3 cards over my first 3 turns. And the successes in the population is going to, again, be the base probability usually. So that's a little bit of an example of how you can use hypergeometric math to help you decide. So with that knowledge, let's revisit the opening hand problem we started this video with. So here, remember, we have an island, a mana vault, a damping sphere, and a metalworker, and we've got 2 choices. Choice number 1, cast metalworker on turn 1, and hope we get an artifact so we can cast Arcum on turn 2. The second choice is we don't cast metalworker on turn 1, and instead we cast Arcum on turn 2, and hope we draw into a cheap 1 or 0 mana cost artifact creature we can then use to cast and then play Arcum and then activate Arcum by turn 3. So to answer this question, to round this down, we'll just say by turn 2 because that's the math we've got here for both of these, even though realistically for scenario B we could actually probably say the odds of drawing a cheap artifact creature by turn 3, but to make this simple we'll just say odds of drawing an artifact by turn 2 or odds of drawing a cheap artifact creature by turn 2. So for odds of drawing an artifact, we're going to set the population size to 95, which is, because our opening hand is 4. At this point, we're looking at a mulligan, so we haven't actually looked at our hand from our first one. So our sample size is going to be 2, so that'll be the draw from the first card for our first turn, and the draw from the second card, which will be from our second turn. So our successes are going to be, the successes in population is going to be for scenario A, which will be, I believe it'll be 3 actually, because it's we've got 3 artifacts in our hand already, which is Mana Vault, Damping Sphere, and Metalworker. So this will be 48. And then the successes in B are going to be 6, because it's going to be 3-man lands that are not conditional, like Urza Saga or Mana Vault. And the second one's going to be 2 artifact creatures and 1 mana artifact creature, like 1 CMC artifact creature. Anyway, I ran the numbers on this, and the hypergeometric math for scenario A is 76.8%, and the hypergeometric math for scenario B is 12.3%, which is, we've got 6%, like 6% off our first draw to get this, and then 12% off our second, and we've got 48% off our first one, and we've got 76% off our second. So generally speaking, based on the math, we should cast Metalworker by turn 1, and because the odds are much higher for us to get an artifact by turn 2 to cast Arcum than it is to get a cheap artifact creature by turn 3. And for those wondering, this number becomes like 18% if we change it to drawing 3 cards versus drawing 2 cards. Anyway, hopefully that makes a little bit of sense. I know math might not be a strong suit, so I'm really sorry if this isn't the video for you, but the math is really important because sometimes you have to make a decision based on probability, so knowing some rough math can be really helpful. So you might be thinking, well, hey, I can't actually bust out a hypergeometric calculator during my tournament game because that's outside assistance. What can I do, Zach? So I'm going to give you some mental math, and you're probably going to get confused, and if you do, I'm really sorry. But hopefully this will make some sense to some of you at least. And at the end of the video, I'll give you an even better table which you can use to refer to more consistently, and hopefully that'll help you make a better choice. So first of all, how do we convert from base probability to hypergeo in your head? So first off, you need to remember the base probabilities. Know these numbers, learn them. If nothing else, please learn these numbers. Knowing the base probabilities can help you unlock everything else in this video. So know the base probabilities. In other words, know how many of the given card you're dealing with are in your deck. And the second one is know how many cards you're drawing. So, like, for example, if you're mulliganing, usually the number is going to be 2 or 3. It's going to be, I need to have this by turn 2, or I need to have this by turn 3. If it's turn 2 or 3, this is what hypergeo matters. If it's by turn 1, then just refer to base probabilities. That's going to be as close as you need to get it for your problem, right? Your base probability will be your friend if it's just, I need this card by turn 1. But if it's a question of, I need this by turn 2 or 3, then hypergeometric math really is important. So some numbers or some variables to explain. So we've got n here for the formula, which is number of cards to draw. B is the base probability. You could also offset the number of cards from drawing from your opening hand, but for simplicity, I would argue that it's not worth the effort. So just use the base probability for these formulas. And then the last one is we've got E, which is the margin of error. Now for this formula, well, we'll do 0.05, which is 5% per card you draw. So for each card you draw, the margin of error to offset is going to be 5%. So if you're drawing 3 cards, the offset is going to be 15%. If you're drawing 2 cards, the offset's going to be 10%. So the rough formula or equation here for the hypergeo is going to be n, which is the number of cards you're drawing, times b, the base probability, minus the margin of error offset. Or better put, it's going to be n times b minus 0.05 times n. So going back to our example, chance to draw an artifact creature over 3 turns, it's going to be 3 times 26% minus 0.05 times 3. Or better put, 3 times 26% minus 15%. And if we do the math on this, it's going to be 63%. And compare that to the actual hypergeometric math, it's actually really close here. It's 63.9%. So over 3 turns, the chance of drawing an artifact creature is typically going to be 63.9%. It's also worth noting that if B is 50% or higher, this method doesn't work. So let's just quickly recap. I just threw a bunch of words and math at you, and if you're not a mathy person, you're gonna be like, what is going on here? So again, basically the way to think about it is take the base probability, times it by the number of cards you're drawing, and minus either 10% or 15%. So if your base probability is 26%, times that by 2, which would be like 52%, and then minus 10%, it's going to be 42%. If your base probability is 26 and you're drawing 3 cards, it's going to be like 75% minus 15, which is going to be like 60%. Just some rough math like that, and you can round the numbers if you need to. Just times it by 2 or times it by 3, then minus 10 or minus 15. Hopefully that makes some sense. But again, if your B is above 50%, that doesn't work. Now, I don't want to belabor this point by too much because the B above 50%, as far as I know, there's only one condition here where that matters, and that's for the drawing an artifact, which is for our very synthetic example. But if your B is above 50%, this quick little formula does not work. And instead, you need to do H equals 1 minus B divided by N. So again, if B is 51, then and N is 3, you'll divide 51 by 3, which is 17, and you'll then do 1 minus 17, which is 0.83. Again, this won't come up too much. Please don't belabor this, but that's how you do it. And if that's like confusing to you, there's another roundabout way you can do it, which is basically for each card you draw, add B divided by N. So if you're drawing 2 cards, it's B plus B divided by 2, which is 51, plus 51 divided by 2, which is 26. That's 75%. And if N is 3, it's going to be B plus B divided by 2 plus B divided by 3, which is 26 plus 17, which is 92. Again, these are approximates. These are just rough numbers to get you close to it. It doesn't really matter if you're out by 5% because it's just some quick math at the end of the day. Still confused? I don't blame you. This is a lot of math. You play Magic. You probably don't do a lot of math. And if you do math, good for you, man. I did an engineering degree as well, and I'm not here to brag about that. But yeah, look, it's totally okay if you're confused. Here's a table. If you can remember nothing else in this video, just try and remember this table because it'll get you unstuck. And especially these 9 numbers. These other ones here, they don't really matter as much. These ones do. So for artifact creatures, the base probability is 26%. H2, which is drawing 2 cards, it's going to be like 48.8%. And then H3 is going to be 63.9%. For lands, and mana, it's going to be 41 as the base probability, 69.5, and then 83.4. And then for blue mana sources, it's exactly the same as artifact creatures, 26, 48, 63. And then you've got the numbers here for blue pitchers and for artifacts. Again, all of these are rough simplifications. A lot of these don't factor in your opening hands, but the numbers don't change drastically when you do factor in your opening hands and things like that. But either way, these are really valuable numbers to know because they can help you make decisions during your games. So again, why does this matter? Well, during deck construction, this can help inform you about whether your deck has a certain number of things that your deck needs. Like, do I have enough blue sources to cast Arcum? Do I have enough ramp to cast Arcum early? Do I have enough artifact creatures to do the Arcum thing? And that's like one aspect of this. But usually, most of the time, we're basing things off a primer list and we're only tweaking, 5 or 10 cards in general. So more importantly, knowing the mental math of hypergeometric math stuff can be really helpful when deciding during mulligans to know how risky your hand is. You might think, oh, this hand would be great if it just had a blue mana source. Well, how risky is it to keep a hand that doesn't have a blue mana source? We can look at the table. We can go, well, by turn 3, we have a 63.9% chance of drawing a blue mana source. And then you can say, well, is that risk acceptable to you or not? In some cases it probably is, but some cases it might not be. And then you might think, well, if it's not acceptable and you need to absolutely have Arcum by turn 3 or whatever, then maybe it's not a hand you need to keep. So sometimes you'll have gameplay decisions like mulliganing, or like in this example here with the metal worker, where you might actually need to make a decision. I'm going to do A or B. I need to know based on numbers what the better outcome is going to be, and the hypergeometric math can help you with that. Again, I know there's a lot of math here, so if you can take nothing else away from this, just try and remember this hypergeo table and know that if you're drawing a card, the probability of a given outcome goes up, not down. But that doesn't mean you can be reckless. 63.9%, yes, it's above 50%, but it may not be enough. But it might be enough. It's also helpful to note that, some bets are more worth taking than others. For example, if you've got a great hand, but you just need 1 more mana, that might be a better bet to take than, say, I need 1 more blue mana. So that might help inform your decision as well. Either way, hopefully this video on hypergeometric math has been helpful. Again, if nothing else, please just remember these 9 numbers, or at least try and understand what they are for your deck, because they can help you make better mulliganing decisions. Anyway, that's all I've got time for today. Hopefully this has been informative to you. Check us out on the Arcum Discord. We'd love to have a chat about the deck there if you want to. That's all I've got. Thanks for watching.